All right, number 1, we're asked about domain and range. The domain for all exponentials are going to be all reals. Your range, it's going to be y is greater than your k value, which is 0. So transformations, there's no h or k, so we're not shifting left or right, so I'm going to say none. This has a horizontal asymptote. All 1 through 3 are all going to be horizontal asymptotes, and so it's y equals whatever your k is, which is 0. So table of values, I would try -1, 0, and 1. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. Make sure you don't ever cross your horizontal asymptote. Number 2, the domain is all reals. Your range, y is going to be greater than your k, -1. Here we've got an h and a k, so h is -3, so we're on left 3. That's a -1 for a k, so we go down 1. Horizontal asymptote at y equals whatever k is, so y equals -1. I'm going to put a dotted line there, a dashed line for my asymptote. The table of values. Now I'm going to be a little more strategic because of the +3 up there. If I want a -1 total, x has to be -4. If I want a 0 total, x has to be -3. If I want a 1 total, I have to have a -2. Another way of viewing that is h was -3, so I put -3 in the middle, and then I just surrounded it. So plug in -4. The exponent becomes -1. 1/5 -1 is 5. 5 times 4 is 20. -1 is 19. I'm not even going to bother graphing that point. It's too big. Plug in -3. Becomes an exponent of 0. 1/5 to the 0 is just 1. Times 4 is 4. -1 is 3. Plug in negative. So I get 1/5 times 4. That's 4/5 minus 1 is -1/5 or -0.2. All right, then number 3. Domains are real. Range y is greater than 0. No translations. Horizontal asymptote. Y is equal to 0. I can go back to using -1, 0, and 1. So I get 12, 6, and 3. -1, 12 doesn't even fit on there, so I won't bother. We're approaching that 0. So there's my graph. Then starting with number 4, we get into logs. That's the inverse of exponential, so everything kind of switches. Oops, sorry, I meant to start with domain. So my domain is x is greater than 0. We don't have an h value to shift it. My range is all real numbers. There are no h and k's, so there's no translations. These are vertical asymptotes, and so it's an x equals equation. It's x equals whatever h is, which is 0. For my table of values, I'm not going to pick the same ordered pairs I picked last time, or the -1, 0, 1. Instead, I'm going to be taking log base 3 of the numbers I choose. So I'm going to choose 1/3, 1, and 3. log base 3 of 1. Sorry, I don't know why I wrote I did not mean a negative in front of my 1/3. Log base 3 of 1/3 is -1. That's where the negative goes. Log base 3 of 1 is 0. And log base 3 of 3 is 1. Make sure you don't cross that vertical asymptote. Number 5. There's no h here. There's no parentheses around the x plus 2, so there is no h, so it's still x is greater than 0. Your range for every logarithmic equation is going to be all real numbers. This one has a k value of 2, so it shifts it up to vertical asymptote at x equals 0, since there's no h value. So I'm going to pick 1/3, 1 and 3 again. Log base 3 of 1/3 is -1, plus 2 is 1. Then I get a 0 plus 2 is 2, and then a 3. Number 6. Domain x is greater than, now there's an h value, h is -2, because we have to switch signs. So x is greater than -2, our range is all reals. That h value shifts it left to vertical asymptote, x equals where that h is, the -2. Since that's not a 0, I'm going to go ahead and put a dashed line there on my graph to remind me of that one. And so I've got to be a little picky about my x values. If I ultimately want to end with a 3, the x would have to be 1. If I want to end with a 1, I need a -1. And if I want to end with a 1/3, I have to have, you can write this up here, x plus, you want x plus 2 to equal a total of 1/3. You see that you've got to subtract 2. It's the same as subtracting 6/3. 1/3 minus 6/3 is -5/3. -5/3 can also be written as -1 and 2/3, or -1.67. And so now, when you plug those in, I get -1, I get 0, and I get 1. Connect the dots, don't pass your asymptote. Alright, we've got cell phones, right? An exponential function. We had an initial value of 285. It's growing, so it's 1 plus 75. Change that to a decimal, 0.75, and that's to the t power. There's your equation. For part B, they want you to plug in the number of years now. So t was the number of years after 1985, so 2005 is 20 years after that, so plug in an exponent of 20. You can plug that in the calculator. And we get a large number. So we're looking at 20,682,633. So clearly a 75% growth is, not sustainable, but it's also possible there could be 20 million cell phones. Okay, an adult takes 400 milligrams of ibuprofen. This is going to decrease, so this is exponential decay. So your initial amount of 400 will get multiplied by 1 minus, it's decreasing by 29%, so minus 0.29 to the x. Then for part B, they want us to plug in 6. And so we get about 51.24 milligrams. Number 9, our initial value is 8, so y equals 8 times b to the x. Let's go ahead and plug in x and y, so I'm gonna go ahead and plug in 4 right there for x. Go back and erase my y and put a 2048 in there. So whatever your 0 is, it's going to be your initial value. The y value goes with it, so 8 was the a. So the other order pair is just going to be x and y. And we're using, I'll write the equation over here. In case you're not sure, it's y equals a times b to the x. That's the equation we would be using. So I plugged in the a, the x, and the y. Got to solve now, so I'm going to divide by 8. So b to the 4th is equal to 2048 divided by 8, which is 256. Then I would take the 4th root. Since that's an even root, I would be doing plus minus, but I know b has to be a positive number, so I won't even bother with the negative here. I would just have to throw it out. So the 4th root of 256 oops. That's 4. So we got b to the b equals 4. So now we can write the equation. Our initial value is 8, and b is 4. So we have y times, or y equals rather, 8 times 4 to the x. Then the next one I get negative 3.125. That's my y. My a is negative 0.2. I don't know b, but it's raised to the negative 3. So I divide by negative 0.2. So b to the negative 3rd is equal to 15.625. I can't do a cube root because it's negative, so instead I'm just going to take it to the power of the reciprocal, negative 1/3. So I'll take 15.625 to the power of the negative 1/3. I'm going to type that in the calculator. I get 0.4. So the equation then, initial value is negative 0.2. B is 0.4. That's to the x. Number 11. The y value is 15/16. A value is 15. B is to the 2nd. I'm going to divide by 15. When you divide the 15, that divides the numerator. So the 15s will cancel. So you get 1/16 equals b squared. You're going to square root. Normally I have to do plus minus, but we get to throw the negative out for the b. B has to be positive. Square root of 1/16 is 1/4. So the equation is y equals 15 times 1/4 to the x. All right, now let's go to the back page. Okay, number 12, I can write both of those as powers of 4. So the left side can stay the same. 64 is 4 to the 3rd, so I'm going to have to take its exponent of 3, distribute it to the x minus 3. So the exponent becomes 3x minus 9. Now that the base numbers are the same, I know the exponents have to equal each other. X plus 35 has to be equal to 3x minus 9. So I'll subtract my x and add my 9. So 2x equals 44, so x has to be 22. And 13, they're both powers of 2. That's 2 to the negative 1, and 16 is 2 to the 4th. Distribute to your exponents. So I have 2 to the negative x plus 3. 2 to the, distribute your 4, so 12x plus 4. Set the exponents equal to each other. So add x, subtract 4, divide by 13. So x is negative 1/13. Number 14, they're both powers of 6, so 36 is 6 squared, so I got to bring it up, so it's 6 to the negative 2. 216 is 6 to the 3rd, so distribute the exponents. Negative 2x minus 16. This is an inequality this time. Distribute the 3, 3x minus 9. So negative 2x minus 16 has to be less than or equal to 3x minus 9. I'm going to subtract my 3x this time, add my 16, divide by negative 5, that flips my inequality sign. So x has to be greater than or equal to negative 7/5. Oops. Number 15, rewrite 3 to the 5th equals 243. Number 16, 4 to the 3rd equals 64. 17, 9 to the 1/2 equals 3. 18, 5 to the negative 2nd equals 1/25. I just wanted you to rewrite those. Start with number 19, we write in log form. Log base 2 of 8 equals 3. Number 20, log base 3 of 9 equals 2. Number 21, log base 8 of 1/64 is equal to negative 2. Number 22, log base 1/3 of 1/9 equals 2. Now we evaluate. 5 to some power is 25, well that's 2. 125, you actually have to cube root 125 to get 5, so that means as an exponent that's 1/3. 4 to some power, 4 to the 3rd is 64, but I want to move it to the denominator, so it's got to be a negative, so negative 3. 8 to the 3rd, let me just confirm, I think it's 8 to the 3rd. Is 512, yep, that's true, so it's 3. 27, I actually have to cube root 27 to make it a 3, and I have to move it to the denominator, so it's going to be negative, and a cube root is an exponent of 1/3, so it's negative 1/3. Expand. So log base 2 of 5, now we move to the denominator, so minus the exponent of 3 becomes a coefficient on log base 2 of x. On number 29, log base 5 of 2 plus, the 4 is going to become a coefficient, 4 log base 5 of a plus the square root is going to become a coefficient of 1/2. 1/2 log base 5 of b. Number 30, we condense. It's going to be a single log base 3. It's no fraction. The 2 is going to become an exponent on the x. The 3 is going to become an exponent on the y. So it's going to be x squared times y to the 3rd. Number 31, we have log base 7. It will be a fraction because I see subtraction involved. N goes in the numerator. The 2 is going to become an exponent on the 3, so it's going to make it a 9. It goes in the denominator. Then I have plus, so now we go back to the numerator. 4 becomes an exponent on m, so m to the 4th. So log base 7 of n m to the 4th over 9. Number 32, I'm going to solve. It's just a log on one side, so I'm going to rewrite it. So the 4x minus 20 is equal to 4 to the 5th. That 4 to the 5th is 1024. So add 20. So 1044. 261. Then we've got both of these have log base 9s, so we can drop them. We know that the 3x squared has to equal 2x plus 1. I'm going to set it equal to 0, so I'm going to bring everything to one side. I need the 3x to be negative. Okay. So x equals negative 1/3 and positive 1. Negative 1, if I plug in negative 1/3 to check it, negative 1/3 times 2 is negative 2/3 plus 1. Oh, that still becomes positive, so that's okay. So they both work. Number 34, we've got an inequality. So on the inequality, you keep the x minus 3. If you want to keep the sign the same way, you got to keep the x minus 3 on the left side, and the 10 to the second goes to the other side. So x minus 3 is less than 100. Add your 3. X has to be less than 103. Up before I circle that answer or box that in, I've got to remember domain restrictions on a log. So let's think about the fact that we're taking the log of x minus 3. X minus 3 has to be greater than 0 because we're taking a log of it. So if we add 3, we know that x has to be greater. Oops. I'm adding 3, so x has to be greater than 3. So that's my domain restriction, so x can't be everything less than 103. I've got to combine those two things together. X has to be between 3 and 103. All right, number 35. They're both logs, so we can just drop the logs. 8x plus 5 is greater than 6x minus 18. So I'm going to subtract the 6x, subtract the 5, divide by the 2. So I've got that, but I have to consider domain restrictions. So let's think about, there's two logs, so I have to think about both domains. So 8x plus 5 has to be greater than 0. So 8x is greater than negative 5, so x is greater than negative 5/8. That's one domain. Let's consider the other one now. 6x minus 18 has to be greater than 0. I'd add, I'm going to run out of room, I would add 18 and divide by 6, so if I do both of those things, I get a total of 3. X is greater than 3. So x has to be greater than negative 1/8 and greater than 3. So in order for both of those things to both be true, the x has to be greater than 3. That's the more restrictive of those two. So now think about this answer within the domain. X is greater than negative 23/2. Well, that's great, but until we get to 3, it doesn't fit in the domain. So we get to throw out part of this and actually summarize it with x is greater than 3. That's the part of the answer that's within the domain. Because a negative, like negative 1, for example, it fits this, but if you plug it in, it gets thrown out. It doesn't fit in the domain. So you can't use just every number greater than negative 23/2, but as soon as you get a number greater than 3, then it's going to work. Okay, moving on to number 36. I've got the 3 that's going to become an exponent on the 4, the 2 is going to become an exponent on the y. We have to start with that. 4 to the 3rd is 64. We get a y squared, so now 64 equals y squared, square root and plus or minus, so y equals plus or minus 8. But I can't use the negative 8. When I throw that in there, it doesn't work, so we can throw that out, so only the positive 8 is going to work. Number 37, we've got to condense the left side. So we have to multiply the 9 and the x, so we get 9x. So now we can drop the logs, so 9x has to equal 54. So x has to equal 6. Looks like that's going to work. 38. We have to condense on the left side. We've got subtraction, so we're going to do division. So it's 3u plus 14 over the 5. So 3u plus 14 over 5 is equal to 2u. I would put that over 1 and cross multiply, so 10u equals 3u plus 14. So 7u equals 14, and u equals 2. Looks like that fits in the domain. Number 39. Got to condense. X plus 3 times x, that's x squared plus 3x. So x squared plus 3x has to equal 4. Set it equal to 0. X plus 4 and x minus 1 equals 0, so x equals negative 4. And positive 1, negative 4 gets thrown out, so x equals 1 is the only one that works. Number 40, I have condensed on the left side. Looks like I have to foil this. For sake of time, I'm just going to give you what it is after it's foiled. If you want to foil it out and test me, go ahead. It becomes n squared plus n minus 12. So n squared plus n minus 12 is equal to 8 to the first, which is just 8, so I'll subtract that. So it's set equal to 1. Factor n plus 5, n minus 4 is equal to 0, so n is negative 5. Positive 4, negative 5 is not going to work. 4 is, so n equals 4 is the answer. Great, thanks for watching.